All right. So, as a reminder, we have finished all of the material for this course. We have covered everything from 1.1 up to 14 with scientific notation. So remember, chapter 1, all about fractions. Chapter 2, all about decimals. Chapter 3, all about sign numbers and kind of an introduction to algebra with some geometry and scientific notation thrown at the end. So chapter 3 is a little bit wider in terms of breadth of material. We have some dates coming up, some very important dates that are not too far away. So if you're my Tuesday, Thursday Math 3, our last class is Thursday, May 7th. So we actually will not hold class on the quote last day of classes. So there's going to be exam days. So we will not meet on Thursday, May 7th if you're in my Tuesday, Thursday class, or Monday, May 11th if you're my Monday, Wednesday class, because again, those will be dedicated test days. So if you are in my Tuesday, Thursday class, then final exams are due by 11:59 p.m. May 7th. If you are in my Monday, Wednesday class, then final exams are due by 11:59 p.m. May 11th. So again, we will not meet those days. I should actually edit that down to say that more specifically. Let me say last day, no class. And again, I'm not saying you don't do anything. It's just if you have not passed the final exam, that's your last day to pass the final exam. That would be our final exam day in class. So that's what we'll be doing that day. Our last class, our air quote last class, is us taking our final exam if we haven't already done so. You are free to take the final early. If you have everything else passed, I'll make sure that that's available. And remember that there are very, very strict requirements to take the final. Not everyone gets to take the final. A lot of you will not be taking the final exam. Probably a lot of people not watching the video, if I had to guess. So what are the requirements? Once again, 50th time of the course, probably, maybe 40th. You have to have 80s on all your homeworks and quizzes because that's what you have to get to access the regular tests. Then you have to get 75s on all the regular tests, which are test 1, test 2, part A and B, test 3. So it's 3 tests, but arguably 4 different parts because of the splitting of test 2. So passing those is a 75. And remember, if you get something like a 72, shoot me an email. Maybe we can figure something out. I've been able to do that for many of you. I've gone and looked on my own occasionally. But sometimes if you shoot me an email, I can get to that quicker. And then once you have access to your final exam, and once you take it to pass this course, you have to get a 70 on the final. Same thing, maybe I can find you a couple points of partial credit if you have like a 67, 68, but I'm not going to be able to bring a 60 up to a 70 or anything that extreme. If you don't pass the final, you fail the course. There are no ifs, no ands, no buts. There are no exceptions to this rule. Failing, air quotes, failing means that you earn a sorry, I had to think for a second, an R or a U. If you receive an R, that means that you did not pass up to and including test. I'm sorry, I'm about to say this wrong. Let me write this down. An R means that you passed test 1 and test 2, but not necessarily test 3 or the final. A U means that you did not pass up to and including test 2. Maybe you passed test 1, maybe you passed all the homework for all 3 chapters, but this is just the specific requirements. They don't affect your GPA at all. They don't really have, as far as I know, so take that with a grain of salt, they don't really have any different effect on your transcripts. As far as I have been led to believe, this is more for administrators to be able to tell how far a student made it through the course. So, circling back to the final, remember that there are a maximum of 2 attempts on the final exam. I will not and I cannot, maybe I should say I cannot and I will not, be allowed to give you extra attempts. This is stern Virginia policy. You are allowed a calculator for the final exam. Remember, the point of this course is so that you learn how to add, subtract, multiply, and divide, decimals, fractions, sign numbers, handle some basic algebra, handle some formulas on your own, not necessarily with a calculator. The calculator is supposed to be for the crazier problems where there's something more in-depth going on, and a calculator is just going to get you to the answer a little quicker. Things like word problems where you have to set up and then arrange things and rearrange things, and the numbers are 10, 12 digits long, maybe. That's when we really, really, really want to rely on a calculator. We shouldn't be relying on a calculator to do 3 minus 7. We shouldn't be relying on a calculator to do a half plus a third. We should not be relying on a calculator to do 0.7 times 0.3. These are going to be problems, and I don't mean math problems, I mean issues, types of problems for you moving forward in your later math classes if you can't handle them, especially if you are a STEM student. Now you might say, Mr. Beckner, my STEM classes, I end up with teachers that always let me use calculators. So, what's the point of that? Again, it's a skill that you need to have. Without basic skills, you can't expect to be able to conquer bigger things. What someone might say to relate that is someone wouldn't know how to build a house without first knowing how to lay a couple bricks. How are you going to build a house without your bare essentials, without your basics? And yes, if you're a contractor, you're going to have other people do that for you. So your other people are your quote calculators, but you still have to have that skill in case one of them doesn't show up, in case your calculator dies, that kind of thing. When you're in STEM, when you're going on to things like factoring, you have to be able to do a lot of this signed arithmetic on the fly. You're not necessarily in your head. You can still have pencil and paper, but the calculator is not really going to help you because you have to be doing, say, 4 different calculations at once, trying to find the right one. And I'm making that sound a lot more difficult than it actually is. But the point being that the calculator honestly doesn't help students do something known as simple factoring. You have to have those rules embedded in your brain. You have to have practiced this tens and hundreds of times in order to have that stuff down. So you need to understand this stuff. This knowledge is critical. Okay, you're going on to Math 154 next, to quantitative reasoning, and you're allowed a calculator the whole time. Okay, that's nice, but you're still going to have fraction operations. You're still going to have to dust off adding and subtracting fractions with different denominators every now and then, or multiplying and dividing fractions. And if you put into a lot of calculators, say a half plus a third, it's going to spit out some decimal number when the teacher or the concept or the book or the homework program, whatever, still wants it in a fraction. So it's going to tell you the decimal's wrong. And it's actually wrong unless you put a bar over that particular one, because if you wrote, say, and the answer is not this, but 0.6 to represent 2/3, that's wrong. It's 0.6 bar. It's 0.6666666. So you might say, oh, we'll write 0.7 or 0.67 or 0.67. You're still rounding. And if the point of the problem wasn't to round, you've now made a mistake because you relied on a calculator instead of your knowledge. I know I rant a lot about this, but it is important for you to build these skills without a calculator. So, given that we have basically, 3 days left to teach? Yes. We're going to do some review stuff. Some of it's going to be me giving you questions and I'm going to expect answers. You could do that through a discussion board on Canvas, maybe, for those of you who are still tuning in and trying. A lot of it is just going to be me kind of circling back on topics. And then I might even pull some particular questions that would be good to review, something more specific here and there. But I do just want to do kind of a general review. So again, your last day of classes, which again, we will not actually meet. I will not hold a video lecture. So when I say, quote, last class, that's for you taking a test. It's possible that there will be a password involved for this. I'll explain how you get that password if I have to do that. It's possible that there may be some other differences with how we run the final exam. I'm still getting the kinks worked out with that and how I need to do things. Calculator allowed. Also, make sure you have your, I'm adding this, your formula sheet printed from Connect under Resources. Let me show you where that is one last time. I know I've said it a couple times, but why not show? So remember, we go to Resources, and then Course Files. So that's where our syllabus is, that's where our pacing guide is, that's where our formula sheet is. So you download that, you open it, and I mean, if you got your computer, you can have that open and just go between tabs. That's not a problem. If you have access to a printer, it'd be nice if you printed it out for yourself, especially since then you can write on it as you're using it. Now, you're not supposed to add anything to your formula sheet ahead of time. So you can probably figure out why I'm laughing about that. But again, this is supposed to be what you're starting with for your final exam. It's got all those different conversions that we needed at the end of chapter 2. If you don't have this in front of you, you're gonna have a very difficult time, because I'm imagining that most of you don't know that 1 mile is 1,760 yards. I'm imagining that a lot of you don't know that a mile is 5,280 feet. I'm imagining that a lot of you don't know that what do I want to say? I don't know, maybe most of those are pretty good, but down here, I know most of you don't know an inch is 2.54 centimeters. I know most of you don't know that a pound is 0.45 kilograms. And there's actually another version of most of these, because you can say 1 kilogram is 2.2 pounds, but you don't need that. Are 2 different versions, arguably 4, to go between Celsius and Fahrenheit. The basic idea of a percent times a base gives you some amount that we use for sales tax, discount, simple interest, and commission, but then they also give you those 4 formulas directly, whether I like that or not. Percent change, which is percent increase or decrease. And we said this formula, this is arguably the only formula they really don't give you enough of. In your opinion, my opinion is I still don't even want that up there, but that's me. And the reason I say this isn't enough is because amount of increase or amount of decrease, that's a subtraction, and they're not showing you that subtraction. It's the larger minus the smaller. So that's the one thing that you do have to remember for this formula sheet, is that an increase or a decrease is the difference of the larger and the smaller. I just figured out what that extra beeping is. That's awesome. It's been bugging me all semester since we went digital. I occasionally get this beeping in my headphones when I'm teaching, and I just figured out what it is. And it doesn't even matter to y'all, so I won't say. And then your geometry formulas. There's actually a couple up here that we don't even use, but because geometry is just application of a formula, the type of geometry we do, there really is nothing wrong giving you something like this, this triangular solid. Some people might call it a pyramid, but it's not. The thing to the right of it's a pyramid. This is a triangular solid because it doesn't meet at a point at, say, the top or a side. And this one is a little weirder. Volume equals B times H. What's the B? Well, that's the area of the base. And that base is a triangle, so that'd be 1/2 times the length times the height of that one. Now, when I say height, I mean the flat height, not this height. So again, you won't see that, so don't worry about it. It's just extra. I think, yeah, you won't see the pyramid either, but you will see triangles. You will see all the different types of quadrilaterals, like a parallelogram, your rectangle, I don't know why they have this triangle up here for Pythagorean theorem. I don't think we did Pythagorean theorem in here at all. I'm pretty sure we don't. But again, these got some other stuff that's up here as well. What was I saying? The area and circumference of a circle is right here. You've got your cylinders, you've got your spheres, you've got your, they actually don't put a cube up here. That's interesting, but a cube is just a special case of a rectangular solid. So this right here is really a cube, just the length, the width, and the height are all the same shape, sorry, are all the same length. I feel like I missed saying something. Oh, trapezoid. I think I I said parallelogram, but I didn't say trapezoid. I'm pretty sure I didn't. So trapezoid, parallelogram, rectangle. There's no square up here because a square is a special case of a rectangle. There's no cube up here because a cube is a special case of a rectangular solid or a rectangular box. But this is enough to get you everything you need. This stuff that says LA and SA, please don't worry about what that means. I'll tell you what one of them is, and maybe you can deduce what the other is. SA is surface area. We did not study surface area in here, so do not worry about that. Okay. So that's how you get to your formula sheet. That's what it looks like. Make sure you have it for the final because you will want it. There will be several problems that will be much less fun trying to do without them. All right, so give me a second. I need to move something. And then we will get into some review stuff. All right, here we go. The blank one. So Math 3 review. And we will, of course, go back to the beginning, chapter 1. So remember, fractions have a top and a bottom. And sometimes a whole if it's a mixed number. They can be proper, which means that the fraction is less than 1, aka the top is smaller than the bottom. They can be improper, where the top is bigger than or equal to the bottom. And they can be mixed. Is a whole and a proper fraction. Remember that for a fraction, we call the top the numerator, and we call the bottom the denominator. We can convert between improper and mixed fairly easily. And I say that in quotes because difficulty is subjective, of course, but it's just a two-step process either way you're going. We said to go from improper to mixed, you do remainder division. You take the top and you divide it by the bottom, so you put the bottom on the left, the top on the right. And when I say remainder division, that means that eventually the division just stops, and the remainder is the new numerator. The quotient, which is how many times it divides, is the whole, and the remainder is the new numerator. Denominators don't change. To go from mixed to improper, you multiply the whole by the denominator, which was the bottom, then add, which was the top. This is the new numerator. Again, the bottom doesn't change. Now, I actually want to have two files open. I've been having a little bit more issue. Well, I guess we haven't even really been using Word in here. Sorry, you won't even know about my issues. I need to open a new file. Actually, yes, you do. We have been using Word. What am I thinking about? That's my other class. Sorry, weird morning. I've had a lot of crashing with this, so I want to have examples on one. And the typing stuff on the other, just because of the issues that it's been having. Okay, so example one, we're going to convert. And let's go with 2 3/5. So to the side, I'll take the 2 times the 5, which is 10. Then we'll take the 10 and we'll add the 3, which is 13. That's the new top. So that says that 2 3/5 would be equal to 13/5. That's it. And I'm not going to do multiple examples of each type of problem for these reviews. It's generally going to be one and then we move on. Some things will not get an example. Obviously, I can't cover an entire course in 2 days. Let's go the other way around and let's use literally the same example just to make sure that this still works properly. So let's do 13/5 and convert it. So we know the answer should be 2 3/5. So we'll go to the side and we'll take 5 into 13. Now 5 can't go into 1, so I don't put any number over the 1. 5 can go into 13 2 times. 2 times 5 is 10. Subtracting, we get 3. If there was another number to bring down, we would, but there isn't. So that 3 is the remainder. The 2 is the quotient. So 13/5. The whole is the quotient, which is the 2. The new top is the remainder, which was the 3. The bottom stays the same. And that's it. So, all right, example 1. Some basic properties. Which again, we'll go to the other page. Was that anything divided by 1 is itself. When we say A, just think anything, any number. Anything divided by 1 is itself. I wrote 1. Anything divided by 1 is itself. Anything divided by 1 is itself. Anything divided by 1 is itself. I need to stop trying to write, talk, and think at 3 different speeds. Anything divided by itself is 1. 0 divided by anything, and this is missed so often by every type of math student, is 0, but never a math teacher, I hope. And anything divided by 0 is undefined. Both of these last two are missed all the time. Tattoo these to your forehead if you have to. Sorry, that's an old joke. All right. The different types of numbers. We had prime and composite numbers. Now, these are not the only two types of numbers. There are classifications of numbers like rational, irrational, whole, et cetera, et cetera. I'm just going prime versus composite. Prime numbers means they can't be written as a product besides 1 and itself, which is often pointless. Not always pointless, often pointless. In other words, 1 and itself are the only numbers that go into it. Composite numbers can. So a composite number is something like 6 because you can write it as 2 times 3. A prime number is like 5 because the only way you can write that as a product is 1 times 5. It doesn't break it down. And again, there are types of math, cough, cough, factoring, cough, cough, where writing something as one and times itself is necessary. But when we're trying to reduce fractions, which is what we mostly spent our work on with this type of issue, one in itself is usually not going to be helpful. So please don't take away from this course that writing something as one times itself is never necessary. It is absolutely necessary in later maths if you are a STEM student. What did I want to say about that? There were many ways. Hold on. There were many ways to reduce a fraction. We could use what I call a factored tree, which was where you started with a number and then you branched below it and try to write it as one of those products without using one in itself. Then you'd circle a number if it was prime, you branch a number if it was composite. And then once you couldn't branch anymore, once you have all your primes circled, that number written as a product is just all of the different primes. You didn't have to use factor trees though. We like them for more complicated problems, but you could just kind of do this in your head. You can do what I like to call the erase method, as we talked about in class face-to-face, where if you had 6, you can erase it and in its place write 2 times 3. Let's say you had 12, you could erase the 12 and write 4 times 3, then you could erase the 4 and write that as 2 times 2. You can show the division, top and bottom, by a common factor being a number that goes into both. Or just slash through them and reduce. The last being the, how do I want to phrase this? Most commonly done in the long run with people that have done this hundreds and thousands of times. But one of the main reasons we learned about prime and composite numbers in this course was for reducing fractions. It was very, very helpful for reducing fractions. Please remember that listing factors of a number is very, let me just say different. I don't know that it's very different, but it's quite different. Is different from prime factorization. The outcome, the expected answer is different. So I actually want to go straight to this first. So that'll be what I'll call example 2 on the other page. And we're going to be using the number, I like 36. So for A, we're going to prime factorize 36. And then for B, just going to go ahead and tell you what the difference is going to be. We're going to list all factors of 36. So when we ask you to prime factorize 36, this is where we write the 36. Don't want to have it that far over there. Let me move that a little over. And I'll show it in red. This will be the work. So we take our 36 and we branch. And we just need to write a product that makes 36, not using 1 in itself, because that's not going to help us at all. Now, the way that you do this, there could be multiple different ways to branch, but it'll be the same answer ultimately. I could do 2 times 18. I could do 6 times 6. I could do 4 times 9. All of those would be a perfectly fine start and still get me a correct answer in the end. I'm going to do 4 times 9. I could have done 2 times 18. Feel free to show your work using those. And then if 4 is prime, we'd circle it, but it's not. We can write 4 as 2 times 2, so we branch. But those are both primes, so we circle them. We branch from 9, which is 3 times 3, and we're going to circle both of those because they're both prime. So that says that the prime factorization of 36 is 2 times 2 times 3 times 3. There is an alternate way to write this. You can write this as 36 equals 2 squared times 3 squared. And I believe that back in the homework, in this section, they wanted you to use the exponential notation, but please, when you're using your fractions, at least in this course, you don't want to use exponents because we haven't taught you how to reduce exponents. Now, I can't guarantee that one or two of you don't know that. Maybe you do, in which case be my guess, but I have never, ever used this to reduce fractions moving forward. So you need to recognize that. You need to pay attention to how I've done things because you should have been doing them in a similar way. Now, like I've always said, if you have a way that works 100% of the time, do it. But I didn't teach you how to reduce exponents in here. So that was the prime factorization. The goal was to write the answer as a product of primes so that we can then, again, if this is a fraction that needs to be reduced, very easily see what's in the top and what's in the bottom to cancel. Listing factors of 36, this is just listing every number that will go into 36. The way I like to do this, you can still do this little branching thing, but we're not going to branch from other numbers. We just list pairs of products. Like 36 can be written as 1 times 36, or 2 times 18, or 3 times 12, or 4 times 9, or 6 times 6. I even like to go in an ascending pattern in one column. That way I know when I've looped around and I don't need to go anymore. 7's not going to work, 8's not going to work, 9 would be 9 times 4. We've already used that, so we stop. So the factors are 1, 2, 3, 4, 6, I don't need to list 6 a second time. 9, 12, 18, and 36. We do have to use 1 in itself because 1 in itself do go into that. Listing factors means listing all the numbers that divide into it. Prime factorization means to write the number as a product of numbers that can't be broken down anymore. Two very different goals. So prime factorization for reducing fractions is good because you can see very easily, oh, there's a 2 in the top, 2 in the bottom, cancel. There's a 5 in the top, 5 in the bottom, cancel. Listing factors of a number can also be beneficial, excluding the 1 in itself, because then you've got a collection of numbers that would divide in the top, a collection of numbers that would divide in the bottom, and you find the biggest one and you cancel them. So let's go and try a reduce now. So over here, we'll have an example 3. And I want to have the typed up stuff here. Prime factorize versus listing factors. For example 3, we're going to have reduce. Wrong thing. There we go. Example 3, reduce. And let's go with (48 over 18). And I'm going to do just this one problem several times. We're going to do it with a bunch of different methods that we said earlier. So, version 1. Let's prime factorize the top and the bottom. So the 48, you could list as 2 times 24. You could list it as 4 times 12. You could list it as a whole bunch of different products. I like 4 and 12. 4 is not prime, so we branch. 4 is 2 times 2. But those are prime, so we circle. 12 we could write as 3 times 4 or 2 times 6. Let's do 2 times 6. 2 is prime, so we circle it. 6 is 2 times 3. both of which are primes, so we circle them. So that says 48 is equal to 2 times 2 times 2 times 2 times 3. There's 4 2's and a single 3. The 18, we could say is 2 times 9. 2's prime, circle it. 9 is 3 times 3, both of which are primes, so we circle them. So 18 is 2 times 3 times 3. So we get 48 over 18. Again, the 48 was 2, 2, 2, 2, 3. They don't have to be in order. They don't have to be grouped, but it's nice if they are. The 18 was 2, 3, 3. And then what we can do is we can cancel all common pairs, top versus bottom. So there's a single 2 we can get rid of. There's a single 3 we can get rid of. Then you just remultiply everything together. 2 times 2 times 2 in the top is 8. In the bottom, 3 is the only thing left. So there we go. 8/3 is our answer. Let's take a second approach to this. Method B, if you will. Method 2, if you will. Let's go and show some divisions. So our 48 divided by 18. Maybe you just recognize common factors. Maybe you listed the factors. 18 would be 1, 2, 3, 6, 9, and 18. 48, I'm not going to list. There's a whole bunch of them. And then you say, oh, well, the biggest one I see in common is this. So you cancel them and reduce it. Or, oh, I'm just going to reduce the smaller one, cancel, and then reduce more and reduce more. So I'm going to say 48 and 18, those are both even, so we know 2 goes into both. It's one of those divisibility checks we taught you at the beginning. Half of 48 is 24. Half of 18 is 9. 24 and 9. 9, 3 definitely goes into. You should know that, I hope. 24, if you don't know it off the top of your head, if you add them up, the digits, 2 plus 4 is 6. 6 is divisible by 3, which means 24 is divisible by 3. That was the divisibility by 3 check. So we can divide both of these by 3. 24 divided by 3 is 8. 9 divided by 3 is 3. Same answer. Third way, literally the same way. Let's just show the division instead of dividing by 2 and then by 3, which I meant to show that in red. Let's just say we recognize that 6 goes into both of these. 6 will go into 48 8 times. 6 will go into 18 3 times. Same answer. Another way, instead of prime factorizing, you just break these up into products. Maybe you recognize that 6 is a common factor of both of these, kind of like we just saw over here. So you write 48 as 6 times something. Oops, why did it scroll up? That was weird. So that 48 is 6 times something. 18, 6 also goes into it, 6 times something. You do your division. You know 6 goes into 48 8 times. 6 goes into 18 3 times. Then you just cancel the 6's. And you get your 8/3. You could have also done a 2 and then recognize that 3 would be the next one that needs to go out. A fifth approach, 48 over 18, you can just cross through and say, oh, I know 2 goes into both of these. 2 goes into 48 24 times, and 2 goes into 18 9 times. So this is 24 over 9. And then you go, oh, well, I know 3 goes into both of these. 3 goes into 24 8 times. 3 goes into 9 3 times. And we get 8/3. Or you could have done this one last way, arguably, and say, with your 48 over 18, I know 6 goes into both of these. 6 goes into 48 8 times. 6 goes into 18 3 times, giving us our answer of 8/3. I do not care how you get that problem done. I care that you can get it done. If you don't have to write a single lick of work because you're a math brain, then that's fine. You think I'm going to show my work on my own, projects for this? No, I'm not. But I'm also not taking this test. I'm not worried about losing credit on things. I'm not worried about rushing and making mistakes, generally speaking. I still have to worry about rushing, obviously. But this is stuff I've learned, so I feel less inclined to have to show every step of my work. And hopefully by the time you're a pre-calc student, if you're going that way, you don't feel like you have to show all of this detail. but you can show a lot of detail if you need. You can show very minimal detail if you need. And then some students, like I said, might just say 48 over 18. Oh, I know 6 goes into both of those. It's 8 and 3, boom, done. Same thing. All 7 methods I just did on that one problem would net me full credit on a test. That's just since it's my math lab and it can't see your work. Let's go back. Rates. These are fractions. The words per, for, in, and on typically mean rates. Rate sounds like ratio because rates are ratios and they are fractions. They're all the same thing. But when we talk about rates, we're typically talking about 2 different types of units, like dollars per hour in terms of somebody's salary, or feet per second in terms of a speed, or miles per hour would be another one, or kilometers per second if something was going really, really fast. We could be talking about a unit cost, $3 per package of toilet paper. It's very relevant right now, right? Also a very small package. Unit rates have denominators of 1. You generally don't write the denominator then. Anytime we have a denominator of 1, it is very, 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 very rare that we would want to write that in a final answer of something. Now, we might want to write that for other reasons, but when we're talking about a unit rate, we're just not going to write that. Our rates can be reduced just like any fraction. Like I said, I'm not going to do examples of every single topic. That would take us, well, how long did it take us to get through the material? About 14 weeks, so give me another 14 weeks. All right, some arithmetic with fractions. In other words, you're adding, subtracting, multiplying, and dividing. First of all, I'm going to go ahead and get division out of the way. When you have a division, change it to multiplication and take the reciprocal, i.e. flip the fraction that was after the division. I don't like to say the second fraction because it could be the third or fourth or fifth fraction if there's a whole series of stuff. To multiply fractions, reduce any top with any bottom, then multiply straight across. And I'll put a little asterisk next to that because that's technically just the easiest method. You can multiply and then reduce, but that's the way I emphasize doing this all semester long because it makes your arithmetic easier, especially when you're not allowed calculators, especially when you still shouldn't be using calculators to do this stuff. To add or subtract fractions, you must have a common denominator. Denominator. We typically said we call that an LCD, a least common denominator. You don't have to have a least common denominator. You have to have a common denominator. But we like the least because it keeps the numbers smaller. The LCD is the smallest number that you can divide with the original denominators. You can use prime factorization or list the multiples of each denominator to find your LCD. You can use prime factorization or list the multiples of each denominator to find your LCD. If you use prime factorization, I'm abbreviating that since it's just written above. If you use prime factorization, the LCD is the product of all unique factors, but with the most from any denominator's options. In other words, if one denominator has 5 2's and the other one has 7 2's, the LCD needs 7 2's. One of them has 5, the other has 7, so you need 7 of them in total. You don't need 12. You don't need to add up the number of 5's. If you use, if you list multiples, the LCD is the first match of all denominator multiples. Remember, a multiple is just, let's say we were doing 2, 2, 4, 6, 8, 10, 12, 14, 16. Or if we were doing 5, 5, 10, 15, 20, 25, 30. Remember, I've said, again, I don't care if you're using the multiples. I don't care if you're using prime factorization. I don't care if you can pull this out of your head, out of thin air. I just care that you can find an LCD and then get an LCD. So let's do a quick example with this. So we'll do example 4. Wrong one. There we go. Insert blank page. Wow, that's the same issue I was having before. I got to make sure I have a new page first. Let me see if I can move this. Sorry about this, everyone. Hold it. Come on, let me drag this. Did that fix it? It kind of fixed it. There we go. All right, now we're good. Sorry, this is really fun with technology. And by fun, I mean challenging. Okay. What were we doing? Get an LCD. Or find the LCD. Let me just say find. And let's go from 1/8 and 5/6. And I'll do it with both methods. So with the first method, the 8, if you prime factorize, you'll get down to 2 times 2 times 2. 8 is 2 times 4, 4 is 2 times 2, so you get 3 2's. The 6 is going to be 2 times 3. So we got 2's and 3's. So our LCD needs 2's and 3's, but there are multiples of the 2's, so we take the most from the options. There are 3 2's here. There's only 1 2 here, so we need 3 of them. For the 3's, there's a single 3 here and none from the first, so we need 1. So that tells us that our LCD is 2 times 2 times 2 times 3, which is 8 times 3, which is 24. The second method, which is your multiples, for the 8, we go 8, 16, 24, 32, 40, 48. That's probably enough. For the 6, we go 6, 12, 18, 24, 30. That's definitely enough. I didn't even need to list 30 because we see a match with the 24. So our LCD is 24. Same thing. There's a third method that works sometimes that I'm not going to write down. I'm just going to say, because it doesn't work all the time. If there's no common factors between them, which was not the case with 8 and 6, 2 goes into both of them. If there's no common factors, you can just multiply them. If you multiply 8 and 6, you get 48. 48 is a common denominator, but not the lowest or least common denominator. We really do want to stick with the least because it makes the math much easier. Now, again, I will mention that 48 is a perfectly fine common denominator that will set you up for adding and subtracting. But your numbers are going to be bigger. Your multiplications and divisions are going to be bigger. Your additions or subtractions are going to be bigger. Your reductions are going to be worse. And I will guarantee you, if you don't use an LCD, there is a 100% chance that you have to reduce. If you used 48 instead of 24, if I was adding and subtracting these, which I'm not, you would absolutely have to reduce no matter what. LCDs, it's a flip of a coin. All right. So now that we know how to, or reminded how to find an LCD, how do we get an LCD? You rewrite, this is the way we've been doing things. We rewrite the bottom as the LCD, then divide this value with the old denominator, multiply by the old numerator, and this gives the new numerator. So for example 5, we're going to get an LCD. And we're going to use the same numbers from before, between 1/8 and 5/6. So we know our LCD already, just in the interest of saving time, because I have a lot to cover. It's 24. So we say the 1/8 is going to be something over 24. But we don't know what that something is. To get this number, I'm circling it. I'm not saying it's 0. I'm saying, what is that? To get that number, we divide the bottoms, the LCD by the old bottom, and then multiply by the old top. So the side work is, we say 24 divided by 8 is 3. Then we take that 3 times the 1, which was its top, which is 3. So that's how we get the new top. Comma. The 5/6 is going to be, well, we rewrite the bottom as the LCD, which is 24. And then to the side, we divide the bottoms. 24 divided by 6 is going to be 4. We take that number, we multiply it by its top, which was 5. 4 times 5 is 20. So those are the equivalent fractions, but now they have a common denominator. So if I was asked to add or subtract them, we can now do that. If I was asked to multiply or divide them, I didn't need to do any of this. There's no LCDs with multiplying and dividing. 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 I said it 5 times, and someone's still going to forget it. Please don't forget. So that's how we get an LCD. Again, all of this is reminders, literally not teaching anything new today. So we said earlier that to add or subtract fractions, you must have a common denominator. We took a nice little side track to talk about how to get a common denominator. So now let's finally talk about how to add and subtract fractions. Once the bottoms match, just add or subtract whichever was requested, the tops, and keep the bottom the same. Reduce if you're able to. So here are the instructions for adding and subtracting fractions. Way up here were these instructions. for multiplying and dividing fractions. I have not done any examples with any of those, so let's do a few. And I really like the numbers we've just been seeing. Sorry, example 6. That's not our class. Please ignore that. Example 6. Add, subtract, multiply, divide as requested. Please change. Thank you. Oops, wrong color. For A, let's do 1/8 times 5/6. So this is a multiplication. There's no LCD for this. You just reduce and multiply. Well, 1's not going to reduce with 8, 5's not going to reduce with 8, 1's not going to reduce with 6, 5's not going to reduce with 6, so you just multiply straight across. 1 times 5 is 5, 8 times 6 is 48. Because I was not able to reduce anything here, that guarantees nothing reduces here. So 5 over 48 is our answer. For B, let's do 1/8 divided by 5/6. Now again, there's no LCD. I'm not going to write that anymore. There's no LCD needed because this is division, but it's division, so we have to flip the fraction after it and change it to multiplication. So this becomes times 6/5. Now this one will reduce. And I'm not going to do any of the longer written versions of the reduction. I'm just going to cross through. 6 and 8, 2 goes into both of them. 2 goes into 6 3 times, 2 goes into 8 4 times. And now we can multiply straight across since there's nothing else that's going to reduce. 1 times 3 is 3, over 4 times 5 is 20. C, let's do 1/8 plus 5/6. So we already know that we need an LCD because we're adding or subtracting. We found the LCD earlier. It was 48, right? No, it's 24. So we rewrote, we want to rewrite these fractions so that they have this common denominator. We already did that earlier. I'm not going to reinvent the wheel. So we know that this is going to become, the 1/8 will become 3/24. And if you don't trust that, if you reduce 3/24, 3 goes into 3 once, 3 goes into 24 8 times, you get the original values. Plus, we know 5/6 is 20/24. Same thing, reduce to check if you need to. The bottoms match, so we keep the bottom the same. That is not a 48. We add the tops, 3 plus 20 is 23. Reduce if you're able to, but this is not reducible, so that's the answer. One more. I'm going to swap the order of them just in the interest of avoiding signed math right now. 5/6 minus 1/8. Once again, this is adding or subtracting, so you need your LCD, which is 24. We already know the rewritten versions of these. The 5/6 is 20/24, and minus the 1/8 was 3/24. 20 minus 3 is 17. Keep the 24, so we get 17/24. So that's adding and subtracting and multiplying and dividing of fractions. Not all additions and subtractions are going to start out with different denominators. Some problems are simpler. Sometimes it's just like 1/4 plus 3/4. I give one more, and I'll do that one in fact. E, 1/4 plus 3/4. Hey, they already have matching denominators, so we can just keep that denominator. Add the top, 1 plus 3 is 4. But this one is reducible. 4 goes into 4 once, top and bottom. So that's 1/1, which is 1. Some people would just go straight to the 1, and that's perfectly fine. The middleman was unnecessary of 1/1. Mixed number operations. You can add and subtract mixed numbers. You can't multiply or divide mixed numbers. You have to convert to improper for those. So we do have a way of adding and subtracting mixed numbers because we can actually treat the wholes and the proper fraction part as separate entities and then just have them combined at the end. There were complications with that. There was borrowing. There was adding so much that you end up with an improper fraction inside of the mixed number and having to tear that improper fraction down to a mixed number and then add in the old mixed number as well. But we never discussed being able to multiply and divide mixed numbers because we can't. I don't even know how to multiply and divide mixed numbers, with very, very few exceptions, just because they're special cases. So you have to remember which one you can actually do, because I see a lot of students that want to try and multiply mixed numbers by just multiplying the wholes, multiplying the fraction parts as complete separate entities, and it doesn't work that way. It doesn't work that way at all. Example 7, mixed math. Only going to do 1 or 2 of these. So for A, let's do 2 7/8 plus 5 3/8. And I'm just going to go ahead and have an LCD to make this simpler in one aspect because the point of the problem is not that. So this, you just go ahead and add the wholes. 2 plus 5 is 7. And add the fraction parts. 7 plus 3 is 10. Keep the denominator, which is 8, because we already had an LCD. But this portion right here, this 10/8, is a problem. That's an improper fraction inside of a mixed number that's not allowed. So we have to go to the side and say 10/8, if you do the division, and you can actually reduce this first if you want, is 5/4. You can reduce it last if you prefer, it doesn't matter. You do 4 into 5. 4 going to 5 once, 1 times 4 is 4, subtract and you get 1. So there's your quotient and your remainder. So 10/8 or 5/4 is the same thing as 1 1/4. So now we can go back to the 7 10/8, which we could also call 7 5/4, is now going to be the 7 plus the 5/4 is 1 1/4 from over here. Well, that's just adding the whole part. 7 plus 1 is 8, so that's 8 1/4. Let's just reverse the order of those. Let's say we had 5 3/8 minus 2 7/8. And I always wrote these out vertically in class, and it's still fine. I just want to write them horizontally for the interest of space. So you put the 3/8 on top of the 7/8, and you say you can't do 3 minus 7. Now you might think, oh, wait, yes, I can, Mr. Beckner. You just taught that in chapter 3. 3 minus 7 is -4. The problem with that is you can't do signed arithmetic on the proper fraction part and non-signed arithmetic on the whole part. So it doesn't work. You still can't do the 3 minus the 7 in regard to this problem. So you have to borrow. So this is where we had to borrow. So we borrowed from the 5, and I will write this one vertically, in fact. 5 3/8 minus the 2 7/8. We say we borrow a whole. We borrow from the 5, which will make that a 4. then we're adding that whole to the fraction. So we're adding a 1 here in theory, but we don't really want to write it that way because we got to do 3/8 plus 1. We got to get an LCD and do all that jazz. We said that LCD is always going to be the same as the original bottom. And when you're changing over 1 over 1, it's always 2 over 2 or 3 over 3 or 5 over 5 or 10 over 10 or 8 over 8. It's always the same number top and bottom. So instead of writing that as a 1, let's write it as a fraction where the top and bottom match. 8 divided by 8 is 1. The reason we choose this number is because this number was an 8. So what this becomes now is 4 and 11/8 minus 2 and 7/8. 11 minus 7 is 4. Bring down the 8s. 4 minus 2 is 2. So we get 2 and 4/8, but that reduces to 2.5 because 4 goes into 4 once and into 8 twice. Okay, B, C actually, C. What if we had, I don't want to use the same two numbers again. Let's go with 5.5 times 3 and a third. No, I don't want to do that. 3 and a seventh. Sure, that'll work. We can't do this way. We can't multiply and divide mixed numbers as we said earlier. We got to convert these. 5 times 2 is 10, plus the 1 is 11, so that's 11 halves, times 3 times 7 is 21, plus 1 is 2, 22 that is, so 22 over 7. And then you just multiply straight across and reduce, or reduce and multiply straight across. Well, 11 and 2 don't reduce, 11 and 7 don't reduce, 22 and 7 don't reduce, but 22 and 2 do. 22 and 2 both have factors of 2. 2 goes into 2 once, into 22 11 times. Then we multiply straight across. The 11s do not cancel because they're both in the top. 11 times 11 is 121 over 1 times 7 is 7. That does not reduce. Final answer. Final thing, order of operations. PEMDAS. 4 steps. The first step is P. The second step is the E. The third step is the M and the D. The fourth step is the A and the S. Parentheses, exponents, multiplication, division, addition, subtraction. In the order you see from left to right. Please excuse my dear Aunt Sally. Multiplication and division are two sides of the same coin. If you see a division, then a multiplication, you do them in the order you see them. If you see a subtraction before an addition, you do them in the order you see them. If you see an addition before a multiplication, you do not do them in the order you see them. You have to do the multiplication before the division. I only have like 2 minutes left, so I'm not going to do any of these with fractions. I just want to get down the basics. For A, let's have 4 divided by 2 times 7. Oh, MD, we do the multiplication first. No. You do the division first because it comes before the multiplication. They are part of the same step. So 4 divided by 2 is 2. Then the 2 times the 7 would be 14. If you do 2 times 7 first, that's 14. Then 4 divided by 14, you would think is a fraction, and you would reduce it to 2/7. And I'm not saying your answers can be fractions, but that's not the answer here. B. Let's do 4 minus 2 plus 7. So again, addition and subtraction, same coin, just different sides, so you treat them in the same way. You do the subtraction first. 4 minus 2 is 2. 2 plus 7 is 9. If you do 2 plus 7 first, which is 9, and then 4 minus 9, you'd think it's -5 after having learned chapter 3. But we taught this to you before chapter 3, so clearly that would have to be wrong. At least we'd hope. How about if we had let's change that to a plus, actually. 4 plus 2 times 7. Oh, do the addition first. 4 plus 2 is 8. 8 times 7 is 56. Nope. Multiplications come before additions and subtractions. So that's 2 times 7, which is 14. And then 4 plus 14 is 18. So please be careful with your order of operations. That is one of the biggest issues in the entire world. I see it all over social media. There's fun little order of operations problems that we just get people arguing over. And I love when people are arguing that they're right when they're very wrong. But what are you going to do? Okay, so that is pretty much all of chapter 1. So we'll kind of do a review of chapter 2 next time. Maybe we'll get into some of chapter 3. But we're going to go ahead and call it a day. Per usual, please be aware of all the stuff we talked about at the beginning. Blah, 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 blah. We'll see you next class. Get some work done. Shoot me emails if you have any questions. Yeah, we'll see you next class, like we said.